Hello everyone, in this video we're going to solve exercise 7. For the following model, find the transfer function and the corresponding time constants. And also we're going to determine how long it would take to reach 63 and 98% of the steady state response. Once we find the time constant, then 63% would be just the time constant, and 98% we have to wait 4 tau to reach 98% of a steady state response. For finding the transfer function, we need to take a Laplace transform, and the initial condition is already assumed to be 0 because we are going to find transfer function. So we have 6s xs plus 5xs equals fs. Fs is the input, so if I want to find the transfer function, would be xs over fs, and this xs here I can factor 6s plus 5. So I have 6s plus 5. That's the transfer function, but the problem is not done. We need to find the time constant. And if you remember, the template for our first order system was a tau s plus 1. So this term needs to be 1. I can manipulate it so I would get 1 here. I just need to divide numerator and denominator by 1. So let's do that. Transfer function would be 1 over 5 or 0.2 in the numerator. This would be 6 over 5s plus 1. Now I know this coefficient would be the time constants. Tau would be 6 over 5 or 1.2 seconds. How long does it take to reach 63% of a steady state response? It would take 1 tau or 1.25 seconds. 1.2 seconds. How long does it take to reach 98% of steady state response? That would take 4 tau or 4.8 seconds. In part B, the only thing that changes is that we have the input now. Then we want to find the steady state response. So xs is the transfer function times the input, or fs. Here the fs is given to us. The transfer function was 1 over 6s plus 5. And the input is 18 over s. If I use the final value theorem, so instead of transferring it into time domain, I can work with Laplace domain. It just needs to be s equals 0. That's if I want to find x, s, s, or steady state. So in this case, I have limit of 18s. I have 1s because of the final value theorem. 6s plus 5. We can think of it that this would go away. This would go to 0. I will have 18 over 5. Or 3.6. That would be the steady state response of the system. Now in part C, we want to see that if our input is an impulse, what would be the steady state response? Again, the response is simply transfer function times whatever the input is. Here the input is an impulse. The Laplace of the impulse would be 18. If this was a step, would have been 18 over s. But for this case, it's just 18. Again, if you want to find a steady state, the final value theorem is just saying adding s here. S equals 0. This would give us 0 value. That's what we expected for an impulse.